Hello and welcome back. And in this video, we're going to be looking at finding an element in the linked list. So basically a search operation within linked list. And we also going to take a look at how we can delete items from linked list. Okay, so let's go ahead and get started. I have a REPL open from our last video, and where we had created our linked list, our node class, linked list class, and main driver class. So what we're going to do is we're going to jump onto linkedlist.swift file, and at the top we can create a function. I mean, you can create at the bottom, but it's going to be rather easy for you to see at the top. So that's why I'm going to create it at the top. Func, and we are going to create a function called find. Okay, and we're going to find the key. So we're going to be given a key, and we want to return a nillable node. That means, like, if nothing is found for that key, then we're not going to return, then we're going to return nil. And if we were able to find the item that we are looking for, then we're going to return that particular linked node. Okay. So what we're going to do first thing is we're going to create our current variable, and we're going to assign head to that. Okay. This way, we can iterate over and update the current without losing the head pointer. Now we're going to do a while loop, and we're going to say while current is not equal to nil itself. That means the linked list is not empty, and current, and we're going to force unwrap this because we know at this point current is not nil, dot data is not equal to the key, all right, the key that's being supplied. So if none of these conditions are true, like, or loop until basically these conditions aren't true, right? When they become true, then we actually exit out of the loop. So we say current is equal to current dot next. So what's going to happen basically is you're going to see basically either this condition is going to fail, right? At that time, the while loop is going to end. So current becomes nil and while loop is going to end. Or this condition becomes true, but this condition, becomes, is going to fail as well. That means the current element's data is equal to the key. Okay. So we found the element that we were looking for, found the key that we were looking for in the linked list. At that point, we want to break our while loop. So we don't want to continue forward because we found our data, and that's the node that we're going to return. So the current at this point is going to represent that node. And if current becomes nil, if we reach to the end of the linked list, that means that that element does not exist in the linked list. So we can simply return current because that's going to be nil. So it's going to satisfy our nil condition. Okay. So with that, let's go to our main program, and this is where we're gonna say we can first say, like, our linked list is still good. So we have 6, 7, 8, 9, 10, 11. So I'm gonna comment this one so not to get confused with the output that we're gonna print, and we're gonna say let found is equal to list dot find. And let's say we want to find the key 8, maybe in this case, right? And we're going to print found dot data, and we're going to do nil coalescing, and we're going to say if we didn't find it, just print -1. Okay, so if you run this one, we're going to find 8, so we're going to print found dot data. Okay. Now let's say if we need to find 11, we're gonna still find 11. Now let's try to find 12, and there we go. We have negative printed. That means our find in the list is working good. Okay, so that's our find basically, on searching in the linked list. Now next thing is the delete. Okay, so let's take a look at delete. Delete is a bit involved, so let's take it slow. So we're going to create a function called delete. We can expect a key to be passed. and we can return a node on the node that was deleted. Okay, so we can, first thing we need to do is there are a couple of things we need to check. If our head, right, is nil, so if our head is nil, that means the list is empty. Okay, then we want to return nil, or you can return head. I mean, it doesn't matter because head is also nil, so you can return head. Okay. Now, if it's not nil, we need to you need to keep two pointers. So basically, the way it happens is let's go back, and let's say if this was your linked list, and you had 4, 5, 6, 7, and 2, and you wanted to delete 6, right? What you're gonna do basically, you're gonna take 5's pointer. Instead of that next pointer pointing to 6, you're going to point it to 7, okay? But your current is 6, okay? So what you need to do, you need to keep track of previous item, and you already have a track of next item, okay? Now you could think of, or you must have heard of another kind of linked list called doubly linked list that keeps pointer for both previous and the next, but we can achieve that without having doubly linked list. Like, in the singly linked list, we can achieve that. Now, we are going to jump straight into interview questions, and we will cover, if we need to cover doubly linked list, we'll actually cover it in later videos. But we're going to cover most of the, linked list related questions, and depending upon the need, we'll go back in there. But the concept is concepts that are applied are very simple for doubly linked list. Since the topic has come up, that's why I wanted to talk about it. The only extra information that you have is like previous. So it's rather easy to actually go back and forth. If you notice in singly linked list or in regular linked list, you only have one direction to go. You can only move forward. And if you want to go back, you have to actually keep a track of previous elements, just like we are doing. But you can at max go one, or if you want to keep a track of all of them, then you have to create an array to keep a track of previous elements. But then your space complexity increases, and sometimes it's good to have that, or sometimes it's good to traverse again. So depending upon the need, really, what your algorithm wants. But in doubly linked list case, you can go in both directions. You can go forward and you can go backward because there is a previous pointer pointing to the previous elements. So you can go either direction. So that's one of the main benefits. Okay, back to the question. In head, how do we delete it? So so this is our current element, okay, and we have 5 and 7, okay. So when we are iterating 6, what we're going to do is we're going to keep track of what was in 5, and we're also going to know what's in 7 because next pointer is going to point to 7, okay. So that's the benefit, that keeping both of these track of both of these is when we want to delete 6 and remove it from existence, we can simply point 5's next pointer directly to 7. In other words, we can point 5's next pointer to 6's next pointer. So this pointer points to this one right here. So this line extends all the way. Okay. So I hope that makes sense. We're going to go and take a look in the code, and it will be much more clear. Okay. So with that said, let's go ahead and get our current with head. So head is the current, and we say we also want to keep a track of previous, but we're going to create that element with nil. So we're going to nil initialize it, or optional, create it as optional for Swift engineers, then for everyone else it's nil initialized. Then we're going to do a while loop. We're going to say while current is not equal to nil. Okay, that's the first condition we're going to check. And current is not current dot data is not equal to the key. So exactly same condition that we are actually applying here, right? And instead of just capturing current, we're going to capture previous as well. So we're going to say previous is equal to current before we reset the current. So, and the current is going to be current dot next. Okay, that way previous stores the previous value, the current value, and current stores current next value. Okay, and we iterate over. Now, at the end, if we check if previous is equal nil. So we are checking for the condition where the first element was the element that we were looking for. So data is not equal to key got satisfied because we were looking for the head element. So in our list, we are looking to delete 6, right? So if you're looking to delete 6, previous is not going to be initialized because it's optional, and that's going to be nil. So in that case, we're going to simply say head is equal to the current. Okay? Sorry, current dot next. It's always current dot next. So head is equal to current dot next because current is going to point to your element that you're looking for, right? If that's not the case, then you say previous dot next is equal to current dot next. Okay, so you're simply removing this by pointing next pointer directly to 7. Okay, so take this next pointer is equal to this next pointer, which is 7. So this next pointer replaces this. So this arrow directly points 7, and 6 goes in the for garbage collection. Okay, and at the end we simply return our current if we need to. All right, let's go back and take a look at how what we have done. Okay, so we're going to say let underscore. We don't care about what's being returned, and list dot delete. Key is let's delete 8 first, and we're gonna list dot print list. Okay, and let me comment these two out, and you can see. Okay, so as you can see, 6, 7, there's no 8. We were inserting 8, but it's not there anymore. So there's no 8, 9, 10, 11. Now that's special condition when we wanna delete first element. So our head is going to change. So in this case, we should have 7, 8, 9, 10, 11. We are still able to iterate over the list. That means our list is intact. Now, if we delete 11, then 6, 7, 8, 9, 10. If we delete 12, right, there we go. We have an error. Okay, so we need to account for this condition as well. Okay, so basically what we are doing is unexpectedly found nil while unwrapping. That means we iterated over, right, and a current became nil. Now, when our current became nil, that means that we reached to the end and we could not find that element. Okay, so we need to account for that condition as well. So if this is and current is not equal to nil, right? So that's what we need to check. Else, right? Else, so we say else if current is nil, right? We simply return nil. Okay. And if the previous is not nil and current is not nil, that means we reach this condition, so we should be able to operate. There we go. So there we can actually print -1. Now let's make sure everything else is working. It's still working. So let's do 11, and 11 is being deleted. Let's do 6. Oh, 161. What the heck? Okay. All right. 6. There we go. Okay. So our list is working, and as you saw, like, how the debugging works in this, like you get the print statement. You have some ideas, but the thing is, if you're having a hard time following this, because this is rather complex logic, the pointer based. So I would actually recommend taking this code and putting in Xcode and then putting some breakpoints and then debug it like step by step to see like how basically it's working. But once you do that, like, it's going to be much more clear, right? So hope you guys enjoyed this video. From the next video, we are um, going to start focusing on interview questions if nothing major is left. So we'll see like, how it goes. But yeah, hope you guys enjoy this video, and I will see you guys in next video. Thank you.